Hello, this is Nate, and this is CCNA1 Chapter 8 Subnetting Binary Style. Just kind of giving you a heads up, there are two main ways that I teach subnetting over the years. The other one, the number pattern method, you'll see in another set of videos, but I wanted to create some videos to help you do it binary style, which is the way the curriculum talks about it. When it comes to subnetting, I don't care which style you use, binary or the number pattern, or if you come up with your own. Really, if you're getting to the destination, that is the key point. So let's jump into the binary a little bit here. The first thing I want to talk about when it comes to the binary is octet boundaries. This used to be called classful addressing. A /8, the first 8 bits are the network portion, with the last 24 bits being the host portion. This used to be called a class A, class B if it was 16 and 16, and class C if it was 24 and 8. And you can't really subnet this at an octet break, but you definitely can the /8 and the /16. So you might take one of the octets here, the full octet, and create subnets of this big network. That is the easiest way to subnet, and frankly, it's the most common way to subnet in the field. You'll just take the first octet being a 10, the second octet being, let's say, a building number, the third octet being a department number, and then the fourth octet being the host in that department in that building. It's a pretty common way to do it. So here's an example of subnetting at the octet boundary. This 10 is common simply because it's one of those private addresses. But you notice the 10.0.0.0 would normally be a /8, but I'm going to take that second octet, this first host octet, and instead of borrowing bits, I'm going to borrow the whole octet. So I'm going to have a 10.1/16, a 10.2/16, all the way up to 10.255/16. So what I'm doing is I'm taking that second octet and assigning that as my subnet portion. And it's /16 now because not only is the 10 included, but the second octet is included. So that'd be 8 bits for the first octet, 8 bits for the second octet to get to 16. So the /16 being the subnet of the /8. And this is pretty common, like I said, simply because I still have 65,000 usable addresses, and subnets, folks, that is a huge subnet. You've got a lot of flexibility in each of these /16s, and then you add to the fact that the 10 dot is private, so anybody and everybody can use it. It just has to be translated with NAT. Okay, subnetting on that octet boundary can also be done right before the fourth octet. So in the 10.0, we can take not just this octet right here, but we can take the third octet as well, so the second and the third. So we have 0.1, 0.2, 0.3, 0.4, all the way up to 0.255, then 1.0, 1.1, 1.2, 1.3, all the way up to 1.255. You know, they put this 101 in here, not sure why, but then eventually you get to 254.253, 254.254, 255.255, and then we've reached the end. So each of these subnets, if it's a /24, is going to have 256 possible hosts. Can't use the first one, can't use the last one, so it's going to have 254 usable hosts per subnet. This is a pretty common size for subnets in the field. /24 is 254 hosts. That is a pretty common size for a LAN. Okay, so if you want to simplify subnetting, you end up with a big complicated situation. You just want to simplify it. Cut off at the octet, borrow an octet instead of borrowing individual bits. Then you don't have to deal with the binary or the number patterns. You're just simply taking the octets. However, it doesn't always work that nicely and neatly. So we have to have the flexibility to borrow bits within an octet. And bits within an octet, you notice this is we had /24 here on the last slide, now we have /25. So we're taking one more bit. And sometimes that's called borrowing a bit. That borrowing the bit comes from the first one here in orange, and it highlights it in the subnet mask and makes it a 1. So I have 25 ones here, thus the meaning of the /25. I have 255, 255, 255, 128, which is the conversion in binary. If I have all 8 bits on, that's 255, 255, 255. And this first bit here is worth 128, so that's where this comes from. If I borrow 2 bits, the first 3 octets are all still 255, but now I have 128 plus 64, which gives me the 192. If I borrow bits, though, the more bits I borrow, the more subnets I get. However, the more subnets I get, the fewer number of hosts. We aren't subnetting to create more addresses. We're subnetting to organize our addresses. So the number of subnets, if the more they get, the smaller they're getting. It's kind of like subdividing a space, a warehouse. If you start putting walls in a warehouse, the more walls you put in, the smaller each room is. If I put 2 walls in, I've got huge spaces. But if I put 64 walls in, I got little cubicles. Okay. So, the subnet mask and logical ANDing. By the way, I included these video demonstration slides. I don't usually do that. There are video demonstrations within the curriculum for you to look at. I encourage you to go in, and especially if you want to look at the binary method, go to the curriculum and watch those videos. They walk you through it in a wonderful process. Okay, so to subnet in binary, you have to be able to convert the IP address and subnet mask to binary. Okay, we've done that before. And then logically AND it. Logically ANDing is 1 and 1 is 1. If there's any 0 involved, 0 and 1, 1 and 0, or 0 and 0, the combination is 0. So if you AND an IP address with a subnet mask, that will give you the network address, or the network ID is what I often call it. Okay? And you can do that with Class A, Class B, Class C. I talked about those earlier. But I wanted to make sure you understood the process here of ANDing is necessary. If you take the IP address, AND it with the mask, then you will get the network address. This is literally what the routers do to determine which interface to send it out. Okay. So subnetting, we talked a little bit about a /25 here. So what is it we're doing in the binary? 192.168.1.0/24. This is a specific IP address. Okay, the subnet mask 255, 255, 255, 128. So there's our subnet mask. And I'm going to take and I'm going to AND that. 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. 0 and 1. You notice it's just kind of spitting out what was there before. And if I have 128 as my mask in the 4th octet, then I'm just going to 0 and 1 is 0, and now you'll notice I get the network ID here when I AND the address with the subnet mask. Magic number. I'm not a big fan of the term magic number here. I'll be honest with you. It's the number of hosts per subnet. I don't consider that really magical, but Cisco likes to mention it here. So the magic number is simply the place value of the last one in the subnet mask. So if it's a /25, I have a 1, the last one is in this one. The magic number then is 128, so there's 128 hosts in this particular subnet. If I have a /26, which means I have 2 bits in this 4th octet, then it's 128.64, so there's 64 hosts per subnet, and so on down the line. The last bit of the subnet mask identifies how big the subnets are. So the further to the right it is here, the smaller the size of the subnet, the more subnets may be available. Okay, and then the magic number with that binary, and then ANDing it out. /27, magic number is 32. Okay. If I have a 23, notice a couple of things here. I've now moved to this 3rd octet. I'm borrowing from the 3rd octet instead of the 4th octet. Is that allowed? Yes, absolutely. The number patterns are going to be the same. The difference is we're just working in the third octet, so the ANDing is going to happen here, and anything that ANDs with an all zero is going to be all zeros. So what's the magic number here? The magic number here is 2. However, because it's in the third octet, the number of hosts is 2 times 256, so a /23 is going to have 512 hosts in that subnet. So 2 from this octet times 256, because that's this whole octet, gives you the 512. That's it for this particular part. Next video, I'm going to show you some examples and how to make it work. As always, if you have questions, feel free to drop them in the discussions, or you can email me, nate.wadman@ppcc.edu.